This is Unit 4, Lesson 2, Part 1, and we are solving quadratics by factoring. So up at the top, we have this four-step process that we're working on, and so I'm going to walk you through a handful of these examples and kind of go back to that step-by-step process. This is touching on the stuff that we just did, so now that we're factoring pros, it's really just kind of an additional step to actually solve these equations. So we're going to look at number 2 first. So step number 1 is to make sure that the equation is set equal to 0. So you can see that that's already set here with number 2. We have equals 0, all the terms are on one side. Step 2 is to factor. So think through our techniques that we just did in the last lesson. Technique number 1 is to always look for a GCF, and that's what we have here. So between these two terms, they're both multiples of 4, and they both have a copy of x. So we are going to factor out that 4x, it's a GCF, and then with these we have equals 0. We didn't have equals 0 before when we were just factoring. Those were expressions, these are now equations. Big difference there. So without the 4x, there is an x left behind here, and then negative 2 left behind here. So it's totally factored. We move on to step 3, set each factor equal to 0 and solve for each x value. So we are going to split this up, make these little tables here. So take the 4x and set that equal to 0, and then take the x minus 2 and set that equal to 0, and then we just solve. So this, you can still divide by 4, even though this is a 0. When you divide by 4, 0 divided by 4 is just still 0. And then with this one, you add 2 to both sides. So 0 plus 2 is 2. So those are our two answers. Step number 4 says to write your answer as a solution set, which we've done before. So we do x equals, do your little curly brackets. We've got 0 and then 2. I always just tend to put them in numerical order, but it doesn't really matter if you don't do that. So that's our first example. Next one I want to look at is number 3. It's got a different factoring pattern. So step 1 is complete already. It's already set equal to 0. Step 2 is to factor. So you hopefully recognize this left-hand side as the difference of squares. It's subtraction, and these are both perfect squares. So we set up our factors. And remember, you still always have this equal 0. So that factoring pattern is x times x gives us the x squared. And then the minus 4 is minus 2 plus 2. And when you combine them, they cancel. That's why there is no middle term. So then set each factor equal to 0 and solve. So I can take this x minus 2 and set that equal to 0. Take the x plus 2 and set that equal to 0. So with this one, I add 2 to both sides, and I get x equals 2. With this one, I subtract 2 from both sides, and I get negative 2. So fourth step, write it as a solution set. Use those curly brackets. So I have negative 2 and positive 2. That would be my answer for that third example. All right, next I'm going to do number 6. So number 6, again, step 1 is complete. You can see all the ones on this page. They're already set equal to 0. So we factor, always look for a GCF first, and notice that all of these are multiples of 2. So I'm going to factor that out as my first step. So take out the 2, then I'm left with x squared minus x minus 12, and we always have this equals 0. So then we keep factoring, because this is a trinomial with an x squared. So the 2 stays right here, and we're going to factor the trinomial. So for my x squared, I start with x times x, and then my missing pieces here, they're supposed to multiply to a negative 12, and I need to make sure they combine up to a negative 1. So that would be a negative 4 and a positive 3. They multiply to negative 12, they combine to a negative 1. So it's totally factored. So I take my pieces and set them equal to 0. So if I try to set 2 equal to 0, that doesn't give us anything because 2 is not equal to 0. Then I can take x minus 4 and set that equal to 0. Take x plus 3 and set that equal to 0. With this middle one, I can add 4 to both sides, get x equals 4. With this one, I subtract 3 from both sides, and I get negative 3. And finish off the problem with my solution set. Like I said earlier, I like to just do them in numerical order, but it truly does not matter if you don't. All right, next I'm going to do the one right below it. I'm just trying to make sure that we cover all the different types of factoring that we just practiced in the last lesson. So number 8, it's already set equal to 0, which is good. And then I go through and I try to factor it. And you can see that there's no GCF to take out, but there's a number right here. So this is going to be one of those ones where we have to slide and divide. So we are going to slide the 6 and multiply it by the negative 4. So this is now just an x squared. Your middle term stays, and the negative 4 gets multiplied by the 6, which would make it negative 24. Then factor that like you normally would. So we start with x times x, and then I'm multiplying to a negative 24, and they should combine to a positive 5. So multiplying to a negative means one negative, one positive. I know that for sure. Adding to a positive 5 means the positive should be bigger. And it ends up being a positive 8 and a negative 3. They multiply to negative 24, they combine to positive 5. But this is not what you solve. Remember, you have to finish off the slide and divide. So this 6 that I started with here, I have to divide by that 6. There's going to be a few steps with this one. So divide by that 6, reduce them down. So 3 over 6 reduces down to 1 over 2. 8 over 6 reduces down to 4 over 3. Still not done factoring, because since this didn't completely divide, I have to take this denominator and slide it back to the front. So this slides back to 2x minus 1. This slides back to 3x plus 4, and now I factored it. So this is how you factor this expression up here. So now that it's finally factored, we can set each piece equal to 0 and solve. So set 2x minus 1 equal to 0. I would add 1 to the right and then divide by 2. So I add 1 and then divide by 2. That means my first answer is 1/2. With this one, set that equal to 0, I would subtract 4 and then divide by 3. So I get a couple of fraction answers here. So I'm going to sneak in my brackets, my solution set over here. So I like to write the -1 first, and those are my 2 answers for number 8. All right, so we are going to move on to the back page, do a couple more back there. These ones, we have to make sure that we're paying attention to this first step because we haven't needed to do that yet, but we are gonna have to do that with a couple of these on the second page. So the next one I wanna look at is number 12. So notice that everything is kind of mixed up. Some stuff on the left, some stuff on the right. So make sure we're doing that first step where we have to move everything to one side of the equation. So we are going to add the x squared over here, and when I add an x squared, I get 4x squared, and then we're going to subtract the 81. So it looks like this. There is nothing left on the right-hand side. That's what you need to see. You need to actually see that equals 0 in order to start the factoring process. So that was step 1. Step 2 is to factor. So this left-hand side, notice it's a trinomial, it's subtraction, there's no GCF, so this is actually the difference of squares. 4 and 81 are both perfect squares. So set up those trinomials. For my 4x squared, I have 2x times 2x. And for my -81, I have -9 and +9. And since they're opposites, that's what makes the middle term cancel out. That's why I don't have one. So it's factored completely. Third step is to set each factor equal to 0. So I take 2x minus 9 and set that equal to 0. So 2 steps here. First, I would add 9 and then divide by 2. So that's my first answer. Second one, I set this equal to 0. So to solve this one, I would subtract 9 and then divide by 2. So I get my 2 fractions, positive and negative, 9 over 2. Feel free to turn them into mixed fractions or even decimals if you prefer it that way. So my 2 answers, I have -9/2 and +9/2. All right, we're gonna do 2 more. The next one is the one just right below, number 14. So make sure that you're paying attention to that first step. You're not supposed to have anything over on this side, which means we need to move it over to the left. So I have just a 0 over here. So I'm gonna subtract this x from both sides. So this is still an x squared. When I subtract x from both sides, this ends up being a 10x. And then I'm gonna subtract the 4 from both sides. So 29 minus 4 is 25. That leaves me with nothing on the right-hand side. So always make sure you're doing that step first. I know the whole first page we didn't have to, so it's kind of misleading. We've got this set up now. We look for a GCF, always. We don't find one. So then we start just setting up our trinomial. And since this is just an x squared, I know it's just gonna be x times x. And then to fill in the blank spots, these numbers are supposed to multiply to 25 and add to 10. So that would be 5 and 5. It's actually the exact same factor. So factor them, set them equal to 0. I take x plus 5 and set that equal to 0. This is also x plus 5. I set that equal to 0, so it's going to give me just a repeat of the same answer. And subtract 5. So I get x equals negative 5, and then just a repeat, x equals negative 5. So when I'm doing my solution set, you really just need to write x equals negative 5. You don't even need to put it in the fancy brackets because there's only one answer. All right, one more. Last one we're going to do is number 17. That's this one down here. So again, we need to make sure everything's on one side. So we have an x squared here, an x, and a 21. So we're just going to subtract these pieces over. So the 2x squared stays. We are subtracting the x over, we're subtracting the 21 over, and that leaves us with 0. So we can't start the factoring process until we have 0 on that right-hand side. So look at this 2. It'd be nice if it divided out, but it doesn't. Since it doesn't divide out, we have to use that slide and divide method. I guess I shouldn't say divides out, factor out. So use that slide divide where the 2 comes over here and multiplies by the 21. This is now x squared. The middle term stays. Negative 21 times 2 is negative 42, and that right-hand side is still equal to 0. So I'm going to factor this as if that were just my original problem. So since it's a trinomial, I start with x times x, and then for my missing piece here, I'm supposed to multiply to a negative 42 and add to a negative 1. So that would be negative 7 and positive 6. It's not ready to solve yet because it's not actually factored completely. I have to take that 2 back into account. So I do the slide and divide. So now take the 7, divide by 2, take the 6 and divide by 2. So this one doesn't reduce or divide. So the 2 slides back to the front like this. And then this, the 6 over 2, does divide out to just 3. So I write it as x plus 3. So this right here is how you factor this, well, I guess this one right here. So now, finally, last step, we set each piece equal to 0. I take 2x minus 7 and set that equal to 0. Step 1 is you add 7 to the right. Step 2 is you divide it by 2. So I get a fraction there. And this one, when I take x plus 3 and set that equal to 0, I just subtract 3 from both sides, and I end up with negative 3. So there are my 2 solutions. Fourth and final step is to write it as that set, that solution set. So I have negative 3 and positive 7/2.